Good afternoon, guys. Can you hear me okay in the back? Can everyone hear me? Good, great. My name is Adam Kath. I am an engineering manager at AppDynamics. Today I'm going to be talking about the journey that my team took from a kind of a traditional dev versus ops organizational split into more of an integrated DevOps team. So I do work at AppDynamics, but I'm not really going to be talking about our products. I'm not going to be selling you anything. I'm just telling you my story because this is a topic that's of interest to folks in our industry. So, and I think you're going to get the sense that I'm pretty positive about DevOps. I think it's a good thing, but I'm not here to push it on you. I think that humans learn best by just hearing each other's stories. You know, this is what I went through. And so I'm just going to talk to you about how it was before, why we did this DevOps thing, and how it went. So just so I get a sense of you guys, are you folks mostly developers? Mostly operations folks? Or something else? Oh, DevOps, yeah. What about DevOps? OK. And how about something that's not none of those three? A couple folks. What are you guys? OK. How about you, sir? Ma'am? OK. OK, great. So I think this talk should be relevant to most of you guys. So AppDynamics, as you know, has many products. We have this wonderful AppIQ platform and all these products built on top of it. And that's where we've arrived to in 2016. But in 2012, when I joined AppDynamics, we only had these two products, Java and .NET application performance monitoring. And I think you guys probably all know what the products do. We were getting great traction with those products. But what we found was if you really want to understand how the application is performing, you need to measure it from where your users are, right? From the actual laptop that they're using to access your site, or the mobile phone, or whatever the device is. Because your servers can be just fine, and yet you can have pissed off users. There's all kinds of things that can go wrong on the front end, on the network in between. And so it's important to do this monitoring. So in 2012, we started working on browser real user monitoring. We released that in 2013, and that product is doing well and getting traction. That's the first thing I worked on when I joined AppDynamics. In 2013, we started doing the same thing for mobile applications and released that in 2014. And 2015, we started something called synthetic monitoring, which I can tell you guys a lot more about if you come out to the booth later. But the idea here is we proactively test the key workflows on your site from the outside in, instead of waiting for user traffic to come along and measuring that. So again, I'm not here to sell it. I'm just giving you the context of my experience at AppDynamics. So when we started end user monitoring, real user monitoring, I want to describe how our operations worked at that time. So as many of you know, there's this piece of AppDynamics called the controller, which is this J2EE application where all of the agents send their data to, and it's kind of the hub of AppDynamics. We sell that SaaS and on-prem. When it's running in SaaS, it's in a data center in Chicago, and we have a whole bunch of machines that run the controller. Each physical machine runs one controller. There's no VMs or anything like that. And there's a operations team that operates those controllers. That team is responsible for everything from getting the physical servers sent out to the data center, getting them hooked up and getting the network configured, to running the application, monitoring it, troubleshooting, and fixing it when things go wrong. So that's how our operations team worked in 2012. When my team came along and we started thinking about how do we want to build this real user monitoring product, one of the things that we realized right off the bat was when we give you this JavaScript agent thing and you instrument your application with it, we're going to be getting billions of these beacons sent back to us from all over the world. And a new customer can sign up with us, and all of a sudden they can increase the number of beacons by 20%. So, which meant that we needed to have an architecture that was horizontally scalable. So as opposed to this, like a bunch of these monoliths sitting next to each other, we needed to have more of a thing where there's a load balancer and servers behind it, and we can just add more servers if we need more capacity. So around this time, the cloud was just getting popular. Amazon EC2 was just getting popular. And so we figured that if we're going to need to scale these servers up and down very fluidly, it would be cool if we could try running them in the cloud. So that was the second architectural difference that we introduced. As we thought about it more, we realized it actually made a lot of sense to decompose this application into several different services. Now, I'm not saying that that's what everyone should do all the time. In our case, that's what made sense. And so we had more of a microservice architecture. And then the last thing was, running a database is a big pain. You have to have a DBA, and you have to worry about the disk space and all this stuff. And Amazon offers these cloud-based databases. There's S3 and DynamoDB and a bunch of other stuff. And so we thought, well, maybe this would be easier for us if we don't actually have to run a database. We can just let Amazon run the database and use their APIs to store our data. So we ended up with an architecture for real user monitoring on the server side that was really different from what we had with the controller. And we'd been working on this for the dev team had been working on it for about a year or year and a half, when it's finally occurred to us that, hey, somebody has to run this, right? Okay, we wrote all this code, and someone has to actually run it. And so we now back then we were a pretty young company, not like all your wonderful companies that have great maturity models and everything like that. We were young and we were figuring things out, and it didn't really occur to us that we had to do that. So we kind of sidled up to the ops team and we're like, hey, we made this thing. Can you guys run it for us? And they were very gracious, and they said, sure, we'll try to run this for you. But what happened is that this architecture was so different, and operating it required such a different set of practices and even a different skill set, that we ended up having kind of just one guy on the ops team who specialized in running this set of services. But it wasn't his day job. It was his day job was to run this other stuff, which was already making us lots of money, and now all of a sudden we're kind of borrowing him to do this other thing. So as I said, he was gracious about it, and he tried hard, but a lot of our operational practices were probably things that if I worked for you, you would fire me for doing this. So for example, deployment. So I'm just going to go through some of the challenges that we had. And again, let me be clear. You could have these problems in a DevOps organization too, right? I'm not saying this is necessary and sufficient for everything to be great. These are just the problems we had before, right? So deployment. We had these Ansible scripts that would help us do the deployments, but they were very incomplete. So it would be like this kind of jumping between running a script, doing some manual stuff, running a script, tweaking the script a little bit, running it, manual stuff. And so our deployment process was it was a bit of a mess. It always was scary to us, and we were always afraid that we were going to break things, and sometimes we did. And by the way, not a knock against Ansible. It's not Ansible's fault that we had crappy scripts. Monitoring. So of course, we have unlimited licenses for the best monitoring software in the world, but the best software in the world doesn't do anything for you if you don't look at it. And if you don't actually set it up to have health rules and have alerts and have it telling you, if something's going wrong, and nobody's looking at it. And that is the situation we were in. And the reason I feel we were in that situation is because there was this ownership gap. So the dev team kind of thought that, operations runs this, so they're going to set up all these health rules and all this monitoring and all this wonderful stuff, right? The operations team was like, this is some weird new side thing, and we don't really know much about it, so we're not really going to worry about whether it's healthy or not. And the result was nobody was really setting up this stuff. So we found out after running it for 6 months, we realized that we did have a health rule that said that if the server returns a lot of HTTP 5xx's, that's bad. But the number of 5xx's was 50,000 per minute. So that's when we would get alerted. All right, so that's not a good health rule. I mean, unless you're doing trillions of transactions a minute, that's not a good threshold. So that's another thing that wasn't great. On-call. The operations team did have on-call set up. We use PagerDuty, which kind of just turns your phone into a pager. Many of you are probably familiar with it. But the on-call engineers were not trained in how end-user monitoring worked at all. So if they were to get paged and they were to try to do something, they would have no idea where to start. And there was nothing hooked up to it. There was no alerts that were actually going to trigger the pages. So on-call was a mess. And of course, we developers were just snoozing away happily, blissfully unaware that something could be totally on fire. Now again, we were a young company. and we were growing by leaps and bounds and making all this revenue, and it was exciting, and nobody was really worried about money. But at some point, we realized that, like, hey, how much does this stuff cost? And do we care how much it costs? And is there a budget and stuff like that? Technically, the operations team was responsible for the cost. Like, they were the ones paying the bill, so technically they were responsible. But they were very far downstream of the decisions that actually impact the cost, right? So if the code is using 10 times more CPU than it should be using, there's not much the ops team can do about that. You gotta fix the code. So they were way downstream, they weren't connected. The dev team had no visibility whatsoever into cost. And so naturally, we just wasted a lot of money. This is an interesting one, architecture. So we had a whole bunch of devs that were working on this stuff, and we were always adding new features, and sometimes we would add new services, or we would add new configuration options. Sometimes we would add, Amazon has all these different back-end things like Kinesis and SQS and these wonderful things, and sometimes we'd add a new dependency on one of those things. We would write code and work on it for a while, and then kind of like, show up to, like, hey, it's time to deploy this code, and the ops guys would be like, how do I do this? What is this stuff? How am I supposed to configure it? How do I set up the security groups? Like, nothing, right? So it was just a throw over the wall. And actually, surprisingly, the same thing would happen in reverse, right? So once in a while, a dev would be working on an escalation or a production issue of some kind, and they'd be debugging away, and they would be like, does this machine have Nginx running on it? And like, this new thing had come out of nowhere, and then we would go ask the ops team, and they would say, oh yeah, we added that a few weeks ago because we wanted to be able to log this, that, or the other thing. It was like, that's an important detail. If you're trying to troubleshoot this thing, you might need to know that. So this happened in both directions, where the architectural changes were not communicated, and they were just thrown over the wall, and it caused headaches. So to quickly summarize, deployment, monitoring, on-call, cost control, architectural changes, those are some of the key challenges that we had in the way that we did operations. Now, again, like, you might think it's embarrassing that these are even problems. Hopefully all of your organizations are at a level of maturity where all of these things are managed. But we were a young company, and it was a young product, and we were just figuring it out. It took us about a year to figure out that all these things were real problems. And the first one that we figured out was deployment, because it was so obvious. Every time we did a deploy, it was like taking multiple people, sometimes multiple days to get the deployment done. That's no good. So what we did is we hired this guy, Andrew, who is a chef programmer. And again, like, I don't think this is about Chef versus Ansible. That just happens to be the skill set that he had. So we brought him on. Oh, and also, he's not a serial killer. There's no emoji for like a chef's hat. So, but there is a knife, so I thought that would convey the idea. So he basically came along and he rewrote all that deployment stuff. And he just fixed it up, and he made it parameterized in the ways that it needed to be, made it reliable, and it was great. Around the same time, or maybe part of the way through that, we started working on synthetic monitoring. And so we hired another person named Dan who did the same thing for synthetic monitoring. And after we had been doing this for a while, that's when we were kind of starting to think about those other things. And we're also noticing that when we were debugging stuff in prod, we often needed both skill sets. Sometimes a developer would work on something, and it would be some kind of complicated performance thing that only the ops guys actually had the insight into, like, what kind of machine are we running and how much RAM does it have and that stuff. And conversely, like, you'd be trying to debug some operational thing, and you need the devs, right? So we just found that we were really like these devs were working with these ops folks, these chef guys, like, all the time, and they meanwhile kind of didn't communicate much with the rest of the ops team. And so it was just pretty natural for us to reorg them over. So I want to be really specific, because there's so much like fluffy, happy talk out there about DevOps and what it means, and I just want to be real concrete about what we did. We had an ops org that was centralized, right? It was like there was ops and then there was dev. And the reorg was we took some of the ops people and we moved them under the managers of the dev teams. So at the beginning, there were 2 ops guys, and they went to 2 dev teams. And they just reported to those managers. And when we did that, it immediately became clear that, like, oh, this is all on us. Like, this service is our team. You know, this one team that sits in one part of the building and we're all together. We have to own it. And that's when we started to realize all these other problems were such big problems. Because they had previously been in this kind of limbo ownership gap between dev and ops, and it wasn't clear who was supposed to do anything. When it was all under one roof, it was like, okay, I'm responsible for this. I need to actually make all this stuff happen. So that was kind of our wake-up call, was actually after the reorg. That's when we realized we had to do all these things. So let's revisit some of those topics and talk about how it works now. Deployment is done primarily via Jenkins jobs. So we have a Jenkins server, and it has a bunch of jobs for deploying different types of things. And the jobs have just a few parameters that you can pick, like which environment you're trying to deploy to and which build number. And so you can go into Jenkins and say, deploy this build to this service, and it does it, right? So the nice thing about that is that it's this well-defined UI that provides a well-defined list of operational tasks, as opposed to, you know, a command line where you can type anything. So this kind of made our set of operational tasks very concrete and well-defined. And by the way, developers can trigger this, right? So sometimes DevOps engineers do it, sometimes pure devs do it. It doesn't matter. We always do deployments with two people. Sometimes it's one DevOps person and one dev. Other times it's two devs. Other times two DevOps. Doesn't matter. One person pushes the buttons, and the other person sits and watches and makes sure nothing goes wrong. Now you could say, like, but you have AppDynamics, and you have all these health rules and all this monitoring stuff, and it should tell you if something's going wrong. And I would love to get there someday, where we feel that, you know, the validation is so automated that we can really trust it. But for now, you know, I know that you guys are all trusting us, and that if we go down, then you're flying blind. You can't monitor your apps. So we're just very cautious, and we don't want things to go wrong. So we figure we'll have another person on hand. And we do it in the middle of the day anyway, so there's no, you know, it doesn't matter. It's not like anyone's staying up late to do it. There's a very important test that we do during deployment that we call shadow. So we have our prod environment, we have a staging environment. And we have cloned all the data from prod into staging, and staging just runs on like less scaled down hardware. And we forward traffic from prod to staging, right? So if we're getting HTTP requests into prod, we actually forward those to staging. And then we can verify that staging and prod return the same results, right? Which means that when we are ready to do a code upgrade, we upgrade staging first, and then we make sure that it's still returning the same results as prod, right? So this is a way of making sure that, right, because you can do all the testing you want on your fake QA data. There's no replacement for the diversity and range and weirdness of real production traffic. So if you forward traffic to this other environment, you're getting, you know, that much bigger breadth of testing. And that's something that's actually caught many problems. This has saved our asses at least 5 or 6 times that I can think of that would have caused bad outages had we not done this. And again, you could argue like you should have caught that in QA, but we didn't. And so we caught it here, which is great. We do this thing called blue-green deployments. How many people know what this is, blue-green deployments? Okay, and I guess the other half doesn't. So I'll just briefly explain. This is a way of deploying new versions of the code that has some big benefits from the traditional way. So the traditional way that people deployed code, let's say this is our universe. We've got 3 different services. Each one consists of a load balancer and then a bunch of servers behind it, right? Typical kind of setup. And there's load coming into the load balancer and getting forwarded along. So the traditional way you would upgrade is you would shut down all the V1 services. You would upgrade the code on, like push the new versions of the code onto those machines, and then turn them back on. Or maybe you would do a rolling version of that so that you don't have them all down at the same time, right? That's the traditional way. I'll describe blue-green, and then I'll describe why it has some benefits. Blue-green is the idea that this is all running in the cloud anyway, so let's just make new servers. Or screw those old servers running the old code. Let's make new ones, and they'll run the new code from the day they were born. They'll never know about the old code. So you spin up the new machines. There's no traffic going to them yet, because all you did was spin them up. And then you gradually flip over the load balancer. So one strategy is you send a little bit of traffic to one of the nodes, and you verify that nothing's wrong with it, right? It's not like spewing errors. And when you're happy with that, then you add the rest of them to the load balancer. And now you actually have V1 and V2 code in the same load balancer at the same time. That has implications for how your software has to work. Basically, your software has to tolerate 2 versions of the code running at the same time, right? And if you're curious, we can talk more about specifically what that means afterwards. And then when you're happy, you take the old nodes out of load balancer, and then a few hours later or whatever, you just kill the old nodes. So you've upgraded the service, but you've actually never mutated or changed the servers that were running. You just made new ones. So there's 3 benefits. There's 3 major benefits here. The first one is rollback is very trivial. So let's say we get to this point, and we realize that, oh, crap, the V2 code is bad, right? Well, all we have to do is take the V2 node out of the load balancer, and we're back on V1. You can do that even if you've gotten all the way to here, right? You've fully upgraded to V2, and then you realize that this code is bad. Could be hours later. No problem. Just flip the load balancer back to the V1 nodes, right? Only once you've finally terminated the V1 nodes can you not do it. So that rollback ability is very nice. The second is you don't end up with these snowflake servers, right? Sometimes you have a server that's been running for 2 years, and all kinds of people have logged in and upgraded and messed with the config files, and there's stuff all over, and you don't know what's actually needed to make this thing work versus what just happens to be cruft that's left over. This basically, you're constantly recycling servers, so there's no time for them to accumulate any cruft. So that's a really nice thing. And then the last benefit is that it's very easy to do a 0 downtime deployment because there's no point at which you had reduced capacity. Even if you do a rolling deployment, you have to have spare capacity because one node's going to be down all the time while you're rolling the upgrade through it, right? If you do this thing, then you never have reduced capacity, and your nodes are always online. So again, not saying everyone should do this. Actually, I am. This is pretty awesome. Everyone should do it. So monitoring. So AppDynamics does produce all kinds of amazing stuff out of the box. We actually found that in order to really be confident that our service was not just like fast and not throwing errors, but that it was working, it was actually doing what it was supposed to do, we had to add a bunch of custom metrics, which is fine. AppDynamics has SDKs for this and info points and stuff like that, so you can do it. So we added a lot of custom metrics, and then we defined a robust set of health rules that really tell us that the app is really working. And our health rules have 2 levels. As you know, AppDynamics has critical and warning. And we take very much advantage of that distinction. And the reason it matters is because of on-call. So this is probably the most controversial thing I'm going to say the whole talk. On our teams, the devs are the first line of on-call. So when AppDynamics fires an alert, a critical alert, it goes straight to a dev's pager duty, not to a DevOps engineer, not to an operator. There's no human in between. It just goes straight to a dev, right? And the devs can actually escalate to DevOps. So it's the reverse of the way most organizations work. Why did we do it this way? When we looked at the types of problems that we would have in production, we found that there was typically a shallow fix or approximate root cause and a deep fix or an ultimate root cause. Sometimes there would even be multiple ultimate root causes, right? And we have this philosophy that the system over time should trend towards hands-off operation, right? Meaning the more time the system lives, the less human intervention it should take to keep it working. That's just a principle that we have, which means that when things go wrong, you need to not just do the shallow fixes, you need to do the deep fixes also. And who is it who's actually in the right position to do the deep fixes? It's usually not the ops folks. The ops folks, I mean, it depends how your org works, but they often don't have access to the code or they're not experts in the code. And so they can't do that. They can only do the shallow stuff, restart the services or add more capacity or whatever, right? So we wanted to complete this feedback loop to the devs that basically says, if you write crappy code that causes problems in production, then you're going to be the one who has to deal with it, right? Because they're because they're in the best position to do it, right? And ops can be totally earnest in their effort to get the root cause fixed, but still powerless to do so, right? You know, you could be, if you're in ops and you're on call, you restart the thing, you take a heap dump, you file a bug for the devs, the next morning they come in and they say, well, you know, the heap dump isn't really in the format that my debugger likes, so I can't repro it, so, you know, forget about it, right? Because as a dev, it's just so easy to do that. It's so tempting to say that whatever, this is gone now, so I'm not going to worry about it. So that was our philosophy. That's why we did things that way. So as I mentioned, there's warning and there's critical. Warning alerts just email the application team. And then the dev who's on call is expected to respond to those emails during business hours. You could say that it files a JIRA ticket or something. That would be fine, too. This is how we did it. But the critical alerts will page you 24/7. And all the devs sleep with their phone next to them, not on vibrate, so that they can get paged. So just a few more mechanical details. So on-call lasts 1 week. There's a primary, a secondary, and then it goes to the managers. We actually have the managers in the primary and secondary rotation also for the same reason, which is managers are often in the position to actually prioritize fixing the stuff that makes the system hard to operate. So we want managers to feel the pain, you know, if the system is hard to operate. So the managers are in the primary and secondary, but if those people fail, then it does go to managers because we have to have the buck stop somewhere. You have to acknowledge a page in 5 minutes or it escalates to the next level. Once the dev identifies a fix for whatever it is that's going wrong, they can go to Jenkins and they can trigger, you know, a lot of the fixes. Typically, these would be the shallow fixes, like restarting a service or, you know, adding capacity or, you know, maybe making some little config change or whatever. And then they'll make the deep fixes later. If Jenkins cannot do the thing that you need, and you need to SSH into the machine, currently the devs do not have SSH access to the production boxes. Only the DevOps engineers have SSH. And it's really just a matter of training in the sense that the DevOps engineers, they have this Linux admin skill set where they know what they're doing when they log into a production box. And they know a lot of details about exactly the way things are running on there because they usually wrote the chef scripts and stuff. So if you have to SSH in, you page the DevOps engineer. And DevOps engineers are only woken up by devs who escalated to them. That's the only time they get woken up. So if you're a DevOps engineer and you want a job where you're not going to get paged all the time for some bullshit, you should talk to me after because we're hiring. Actually, I'll make it quantitative. So these are reports from PagerDuty. These are 2 different services on the top and the bottom. So the top one is Synthetic, which is the service that I run. The orange line is all the times where devs got paged. And the blue line is the time where DevOps engineers got paged because it escalated to them. And the x-axis is weeks. The y-axis is the number of pages that happened during that week. So you can see most of the time we're in the single digits of pages to anyone during a week. Sometimes it gets bad. And this is an interesting case where there was a deep fix we had to make, but it took us time to develop the deep fix, right? So it was getting worse and worse and worse. Then we deployed the deep fix, and it fixed it. And as you can see, the DevOps engineers very rarely get paged. On an average week, they don't get paged at all. On the bottom, this is a different service. The colors are flipped just because I couldn't get PagerDuty to give me the right colors. So the blue is the devs, and the orange is the DevOps. In that service, it looks like, you know, devs have to escalate to DevOps more frequently, right? Which is a sign that we need to add more stuff to Jenkins so that devs can self-service and fix stuff themselves without having to escalate. So that was monitoring and on-call. Let's talk about cost. So the way cost works now is pretty simple. We have a unit cost model, which means for every unit of an AppDynamics license that is sold, our contract as the service team is this has to cost us less than K dollars to provide this unit. And of course, the sales team contract is they won't sell it for less than some number J, which is hopefully greater than K, to guarantee that the company makes a profit. We review costs weekly. We use this tool called Cloud Health, which can slurp in your Amazon bill and then let you do like analytics, slice and dice stuff on it, which is pretty nice. I recommend it. And one of the things that we found is that to reduce our costs, we often make improvements that are sometimes in the product code and sometimes in the way we do operations. So for example, if the problem is, our DynamoDB bill is too high, well, that's probably because we're doing too much querying of Dynamo and we need to add some caching or make our queries somehow more efficient, right? That's a product change. On the other hand, if it's that we're spending too much on EC2, then we can buy more reserved instances from Amazon, and they charge you less for that. So that's like a pure operational change. So having both folks in one room working on this together is really constructive. All right, so as you can tell, I think it worked. I'm happy with the result. But just to quickly summarize, we really got rid of the ownership gaps. That was the biggest thing that this did for us. It made it so it's like, OK, you're team X, you own X, period. There's nobody else who's going to bail you out if something goes wrong. And that worked very effectively. It allowed new teams to be very independent and teams to be independent from each other because you're not blocked on some other organization that needs to onboard your application or something like that. For instance, when we added synthetic, the synthetic team spun up and we did the whole thing with no help from any other team. There was no other team we had to go coordinate with, which is, as you guys have worked in companies with bureaucracy and layers of things, that's a huge help when people can just be independent. This thing about paging the devs, I think, has been very effective. We've evolved a culture where if anything serious goes wrong, we write a very detailed postmortem. And you should do this even if you don't do DevOps, of course, with, this is what went wrong on as many levels of depth as I can describe. And here's a bunch of plans that we can make so that this never happens again, or nothing even remotely like it ever happens again. Now, the hard part in most organizations is getting those changes actually implemented, right? OK, somebody said we should do this. How do we get it prioritized? Well, if you know that you are going to have to wake up in the middle of the night if you don't do it, then you have a pretty strong incentive to do it, right? So what happens is that there's this back pressure on feature development. And what I mean by that is this. Often when you hear people talking about dev and ops, they talk about the tension between velocity and stability, right? The dev team wants to push out new features, and the ops team wants the thing to be stable, so they don't want changes to happen, right? So what really needs to happen is that velocity is good, but if the system is getting unstable, you need to slow down a little bit, right? You slow down the feature development, fix what's wrong, fix what makes it hard to operate the system, and then you can go back to developing features. In our arrangement, that happens very naturally because the devs get paged, they figure out there's something wrong, they figure out there's a deep fix that they need to make, and then in the next sprint, we'll prioritize that, which means that we're not doing feature development, right? So we end up naturally slowing down feature development in order to make these operational fixes. And then when everything's running smoothly in prod, then we can go really fast on feature development. So that back pressure on feature development, I think, really helps align those two things. The devs contribute to the operations, obviously, in terms of getting paged and stuff, but they also are writing some of the Chef cookbooks and making some of the changes in Chef and making some of the Jenkins jobs, and that's all wonderful. All those benefits that I just listed, those were things that we kind of hoped for. Those were expected, or at least hoped for. That's what we wanted to happen, and for the most part, they did. There's also some really pleasant surprises, some things that we did not expect to happen and did, and that are great. So, a brief digression about motivation. So all of us who manage people, we're always wondering, how do we motivate people, right? And cognitive science has this distinction called intrinsic versus extrinsic motivation. So extrinsic motivation is when you use these kind of very crass tools to try to get someone to do something, like, I'm just going to pay you more if you do this, or I'm going to punish you if you don't do it, right? That's like trying to motivate someone from the outside. And for most of us, that doesn't actually work very well. Unless you're in sales, just being given more money doesn't actually make you want to do a better job. This is like an empirical observation of cognitive science, and also something that probably we can all relate to intuitively. What does motivate us is some intrinsic factors. And there's a lot of study about what they are. There's a great TED Talk about intrinsic motivation that lists some of these things. One of them is autonomy, meaning I own this thing is my baby, and I'm responsible for it. And that makes you want to take care of it. That's just human nature. You don't need anyone to punish you or whip you or tell you better do this, or I'll give you a bonus if you do this. It's just like, this is my thing, so I'm going to do it, right? That's natural. So when we give people autonomy, when we give this team complete ownership over a service, they get this extra motivation from it, and they're motivated to keep it from having, warts and broken windows and stuff. They clean it up. They keep it working well. And if you have no broken windows, then on-call is fine, right? When on-call becomes a problem is when you're getting paged all the time, and then you look at it and you know the alert is garbage, right? Or you investigate it for a while and then find out the alert is garbage. When your system is constantly spewing errors and doing weird stuff, and you have these broken windows all over the place, then on-call is a nightmare. If your system is basically working such that anything that's like deviating from that is really unusual and is really a real problem, then most people who are like motivated and excited about what they work on, they actually don't mind being woken up in the middle of the night for it. That's my observation. If they feel like this is my thing and it's supposed to work and it's breaking, like, yeah, I'm going to fix it. So that's what makes on-call okay. One thing I was surprised by is how much the DevOps engineers are contributing back to the product itself. So one thing is that they're always there in our sprint planning meetings and in our stand-ups and stuff. And so there's just this natural dialogue. And they're always bringing the perspective of how is this going to work in prod, and what about capacity planning and stuff like that. But it even goes further than that. There's cases where one of our DevOps engineers basically built one of the services that we use. Just because it had to be done and he could do it and it made sense, so he did it. So that was like a really pleasant surprise. The last thing is, and I know I'm getting a little philosophical, so just bear with me for a minute. When devs are kind of like off in their own world and they only get brought into prod when there's some horrible problem, they don't have like any situational awareness about prod. They don't know, how many servers do we have and where are they deployed and how does anything work? You don't have that awareness. When you are really plugged into prod all the time, when you have the developers plugged into prod, then they get it and they're naturally curious, because we're all naturally curious. And they start poking around, they look around in AppDynamics and they see something that doesn't look right to them. Like, why is this thing calling that thing? Or, this call, I thought this call would take like a millisecond. Why is it taking 500 milliseconds? There's just that little bit of curiosity that makes you discover things. And we've had a number of times where people just poking around in our monitoring tools or our logs or whatever, they discover something interesting that turns out to be either a real problem or a real opportunity. So those are some of the really surprising benefits that we got. So I do have to give a couple caveats. The first is that I'm operating on a very particular scale of system. So this is my scale. There's about 45 engineers. There's 3 products. We have a few billion requests a day, a few hundred nodes in production. So if you're running on a scale that's way bigger than that, I don't know. I can't speak to how well that works. And I know many of you guys support, like, I was talking to someone today who supports 6,000 different applications. And I don't even know where you start with that. So I would like to learn from you in that case. I can say that if you're on a smaller scale than this, it will work, because we started on a smaller scale. So I've been through every scale from that to where I am now. To make this work, especially if you're going to page devs, your alerts have to be good. They have to be high signal-to-noise ratio. And your debugging tools have to be good. Because getting woken up with some nonsense and then having to go debug through some crappy tool just doesn't work. Now, luckily, you guys are all AppDynamics customers, so you should not have any problem getting that to work well. There are a few things that my team still leans on. Connor just joined us. On Connor's team, which Connor runs our central ops organization, and there's a few things we still lean on them for. So one is communicating outages to customers. We talk with them, and then they figure out the list of customers, and then they send out a notification. If there's a problem that we detected in our service where the root cause is in some other team's service, then that team will help us coordinate with them. So it's helpful to have a central hub to go through. We have compliance standards like SOC 2 and stuff like that, and they help maintain those across the whole company. And there's probably a whole list of other things that Connor helps us with that are these kind of other things. So I can't say that like we don't use the central ops team at all. Now, a couple things that screwed us up at first that took us a little while to get right. One was accountability. So if something went wrong in our service, initially what would happen is somebody would go yell at Connor, right? And actually they would say, hey, Connor, what the hell's going on with this thing? And Connor would be like, I don't know. I don't run this thing. I'm not involved in it at all. I'm not responsible for it. So he was being held accountable for something that he doesn't actually have any control over, which is not fair to him. So this was just an organizational communication kind of change we had to make to say, no, if something's wrong with these services, you come and blame us. Don't blame Connor. So that was just a shift we had to make. Another thing is, like, you might read some articles about DevOps where people talk about, like, you should have like these 2 pizza teams. It's like a team that you can feed with 2 pizzas, and they run one service. And then like another 2 pizza team runs another service, and then you just have a ton of those, and that's your whole organization. I found that in reality, the alignment is not exactly as clean as that. It's like, sometimes we'll have one team that runs 3 different services, or we'll have 2 teams that share a service. And in those cases, you have to be very explicit about who owns what, right? It's not a problem. It's just you have to be explicit. Figuring out the ratio of devs to DevOps engineers that we have has been a challenge. One is just that it's really hard to hire DevOps engineers. So again, talk to me after if you are interested. But the other is that like we don't need that many DevOps engineers to support our product because we have devs doing so much of the troubleshooting stuff. So right now we have 2 DevOps engineers, and one's always the primary DevOps on call, and one's always the secondary DevOps on call. So these guys are on call all year long, which is not actually fair to them. Now, they get paged very rarely, as you saw. So it's not like they're waking up all the time, but they still have to have their laptop on them, and they have to worry that I might get paged. So that's actually been a challenge for us. Well, one of the things we want to do is a little cross-training where those guys kind of train a few devs to be like capable of doing the DevOps on call, just to spread it around a little bit. But that's just one solution. And then one last thing is Google talks about this thing called an error budget, which is the idea that if your service is supposed to be 99.9% available, then that means that it can be 0.1% unavailable, right? And actually, instead of thinking about it as, oh, we always have to hit this 99%, you can think of it as, okay, we're allowed to have errors 0.1% of the time, right? And if you think of it that way, it's more like a budget that you can spend. So if you just had an outage, and then you just used up your budget, which means you should not do risky things like deploy new code or make architectural changes, right? If, on the other hand, you haven't had an outage in a long time and you've built up a big budget, then maybe you want to do risky things. So it's a way of making these availability SLAs more actionable for us. How does this actually inform what we do? That's a cool thing that I would like to integrate into our process that we haven't done anything with yet. So that's our story. I think I'm going to skip the epilogue and actually, because we only have a few minutes left, and go to questions. So if you guys have questions, do we have the mic? Looks like Omid didn't come back yet, right? I'll just grab the mic. Oh, Connor, would you mind doing the mic thing since you're here? He's got the mic. Yeah. For now, I'll just repeat the question.
With your DevOps folks within your dev teams, and I'm assuming you have multiple groups for this, does the group of different DevOps engineers within those maintain the standards and the best practices, or does each DevOps team pick their Ansible versus Chef versus Puppet tool of choice?
That's a good question. So we kind of, we went radically from one way of doing things to the polar opposite way, which is like totally centralized to totally decentralized. So at first it was like, yeah, every team do your own thing. We're not going to try to worry about coordinating at all. Over time, I think we've realized that that has some drawbacks, because there's real benefits to be had from some knowledge sharing, some best practices, even some shared infrastructure potentially. And so that's something that I think we should move towards a little bit. the way that I think about it is like, it's kind of like you have different dev teams, but you have common coding standards, right? You don't have to have them all report to the same manager in order to have common coding standards. You just have everybody agree to these standards. So that's kind of how I'm thinking about it now, is that there should be some collaboration across the DevOps folks who are on different teams to get some standards. We do have like a few places where that's enforced, like the SOC 2 stuff, but I think it should be a little more than it is right now in our org. Yes, sir. I can just repeat the question. Or
on the related to the question that was asked. So, like, do you, for all the monitoring tools that you're using, is it typically owned by the central ops team, or do you let all the DevOps engineer in individual team kind of configure and do whatever they want to do? And the reason I'm asking, just to elaborate,
yeah,
like, I mean, we have sort of gone from a route of letting developers kind of doing it for themselves to actually having this, like all these big monitoring tools kind of being in this mess kind of thing, and we want to enforce standards. So that's where I'm kind of coming from.
Yeah, I think there's no right answer to this question. In our organization, it's a mix. So for instance, we have one AppDynamics instance that monitors all of our production systems for all teams. Actually, that's another thing that Connor's team runs. I missed it on the list of things that his team does for us. And we all report to that one instance of AppDynamics. That is not a rule that anybody put in place that everyone has to do this. That's just a convention that evolved because it was useful for everyone. We also have a central Splunk instance. However, I think this is an interesting example of how these things can play out. For whatever reason, our Splunk was slow. And my team was getting fed up with it. And so one of our DevOps guys just said, hey, there's this open source thing, Graylog. I'm just going to stand up a Graylog and send our logs there. And so we just did that. And that actually totally solved our log problem for like many months while we tried to, the central team tried to fix the Splunk thing. So it's a bit of a give and take, I feel, where it's, it's like, I think if you just set rules that everyone has to do X, you're really going to stifle the team's ability to figure out what's going to work for them. But if you let everyone do their own thing, it can be a bit of a mess. And if you do have someone who's centrally accountable for it, then that person is screwed because there's no way they can have visibility across the whole thing. I think that the control has to align with the accountability, right? So if you have one team that's accountable for making sure everything works, that team kind of has to be able to control everything. If you are saying that this team is accountable for that, then you should let that team control it. And then maybe this common stuff just evolves in a bit more of an ad hoc way, like conventions that we all follow because they work well. I don't know if that's an unsatisfying answer, but that's my feeling. Yes, sir. The question was, how do we mirror production traffic to staging?
And equally importantly, how do you, at the end of that, compare the results? You said that you compare the staging result with the actual production result.
Right. So I think there's two ways to do it. I think we've actually done it the worst way. So I'll tell you what I think would be the better way, and then I'll tell you how we do it. I think the better way would be if you had a load balancer that was configurable enough that you could actually give it some rule to do this. Because I think that would be simple and elegant and it would just work well. What we've done in practice is for some of our front-end services like have ad hoc code in them that says like when I get this request, I will forward that request onto this other environment. So that was code that we had to write to do it. It works fine, but it's just like, it feels a little hacky. And you have to, there's something you have to worry about, which is I don't want to use too many resources on my production machine just forwarding traffic to this other thing. So we have some throttles and limits in place to make sure that that doesn't happen. And how do we make sure that the stuff is the same, was your question? So one of the things we do, so as you know, AppDynamics generates all these metrics, right? So we would pick a customer, like your company, for example, and we would look at the metrics that were coming out of this metric pipeline from production and from Shadow, and make sure that the metrics were the same, or at least similar enough. It gets a little fuzzy, but it's an application-dependent validation process. It's not like there's some generic HTTP proxy way that you can do it, at least not that I've thought of. You got to think about what does it mean in your application for the thing to be doing the same thing. So if it was e-commerce, you would see that the same orders were coming out of that system and that kind of thing. Anyone else? I think we're just about out of time, but maybe one more question.
Did the dev team have direct server access to do any kind of troubleshooting, or how do they go about doing troubleshooting?
The dev team does not have SSH access to the servers. The way they do troubleshooting is through AppDynamics, through logs, through Amazon CloudWatch, which has its own metrics. So they're basically doing it through monitoring systems. And if they do need to SSH in and run top or whatever, that's when they would page a DevOps engineer. But amazingly, we actually don't have to do that often. We can usually troubleshoot without it. So I just wanted to just put up some info. I'll be at the synthetic monitoring booth if you guys have any more questions. And I'm on Twitter, but I'm not good at it. So sorry. Thank you, guys.